Good afternoon, everybody in my physics classes. Just rolling along here. Let's have a look at what we're going to get done. I'd like to look at resistors in parallel. So we come back to our Scottish flag idea, and we mask out the series bit because we're only interested in a parallel circuit. And then we squeeze things up and make things a bit simpler. In a parallel circuit, the voltage is the same because we're comparing one side to the other. And the current is split because the current drops out as it goes down different branches. That's just year 10 stuff. Let's move on now to year 12. Let's mathematize this, put it into mathematics. The current in parallel is split, which means that the supply current is equal to the current through the first branch plus the current through the second branch plus the current through the third branch, and so on. And they all add up to be the currents that to make the current that goes through the supply. The voltage is simpler. In a parallel circuit, the supply voltage is the same as the voltage across 1, which is the same as the voltage across 2, which is the same as the voltage across 3, which we'll just call the voltage V for the whole circuit. Shrink this down and park it in the corner. And then let's have a look at this. We know that the supply currents add up. And that's from this little wee bit in here, supply currents add up. And we also know that using Ohm's law, we can say that the current is equal to the voltage divided by the resistance. Just rearranging this one here. It makes sense. So then we can have individual things for the currents from here. So the supply voltage divided by the total resistance of the circuit is equal to the voltage across 1 divided by the resistance across 1, plus V2 over R2 plus V3 over R3, and so on. However, the cool thing is we can make this a bit simpler because the supply voltage is the same as V1, is the same as V2. We've only got one V for the whole circuit, so we can put that in there and replace it. Wherever we had these subscripts, we've lost them. Just one number V for the whole circuit. Well, the cool thing is we can then take that out as a common factor. And we can have V times 1 over RT is equal to V times 1 over R1 plus so on. And then we can then cancel the V from both sides because it's non-zero. And we finish up with 1 over RT is equal to 1 over R1 plus so on. Now the cool thing is that's a biggie. We can make that a lot bigger because that's what we're chasing. And in a parallel circuit, the reciprocals of the resistors add up, just like do and die in waves. And the handy little handy little checker is the total resistance should be smaller than the smallest resistance, and we're going to get into that why later on. However, as a little wee subscript here, I'd like to show you the special case where we have only two resistors, 1 over the total resistance, the same formula. You can show that to be the total resistance is the product over the sum for only 2. I'm making a big thing of it. This only works in 2. So we can say that, well, I haven't put a subscript, sorry fellas. RT is equal to R1 R2 divided by R1 plus R2. And to prove that, I will set it as a challenge, but I'll resolve it by proving it at a later date, either on YouTube or on face-to-face in the classroom, if and or when we get back there. Kia ora, everybody.